name is David Jamison. I'm a biomedical engineer and biomechanics expert with Robson Forensic. My job is I do a lot of injury causation cases. So situations where you have a vehicle crash, motor vehicle crash, slip and fall, or a fall from a height or something like that, where the mechanism of that injury, or I should say the cause of the injury, is in dispute. So we are looking at, the totality of the information that's given to try and figure out, knowing what the mechanism of the injury is it consistent with whatever happened in this particular instance? I found out about the field while I was here at Drexel because of all the different, even outside collaborations that Drexel has. So I kind of knew of the field while I was here, and then really the position itself kind of fell into my lap because I was teaching at Villanova and I met with a student who needed assistance in the course she was taking. She was full-time employee of Robson and then getting her master's part-time. And when she emailed me, I saw this Robson Forensic in her signature line, and I was like, oh, that's interesting. What do they do? I ended up talking to her boss. One thing turned into another. Now she's my boss. Initially, I wanted to be a doctor, like a physician. I wanted to be an orthopedic surgeon. And I learned after going to a summer 10-day intensive camp for high school students about medicine that I didn't want to be a doctor anymore. What can I do that's still kind of in that realm, but doesn't involve me having to take MCATs and go to med school and all that? And I always had a love for math and science, so kind of put two and two together, and biomedical engineering is what came out. Keep your options open. And, being in an institution like this, there are so many different opportunities to learn about what's out there. I attended several different career panels while I was here as a PhD student just to figure out, what are my options after I finish. Not everyone wants to go the typical path of becoming, a postdoc and then assistant professor after they get their PhD. There's so many different things that you can get into that you may not even know exist right now. So keep those options open and, utilize what's around you here. There's a lot going on, and if you tap into it, you'll find something. I've been involved with National Society of Black Engineers for going on 15 years now as a member, and being on different board positions at different levels. While I was an undergrad student, I was on the regional board for the society. I've been involved as an undergrad student, as a grad student, and even now, as a working professional. Most recently, I was on the founding board they have a special interest group for healthcare innovation. And so we actually, we do a lot of work trying to really bridge that gap between, folks who are in these, biomedical and healthcare spaces and the actual companies that are doing work in those areas, and trying to really bring those two communities together, especially when you talk about, students and scholars of color who are underrepresented, right? And you want to make sure that we have adequate representation. There's a really good collaborative spirit and environment as a whole within Drexel, and particularly within Biomed. Students were willing to work together and collaborate to get things done. Obviously, Drexel has world-class researchers, so that also helps when you're trying to learn best practices in research and understanding how to conduct studies and how to present your research and what questions to even be asking. The Biomed school as a whole just had a wealth of different faculty to choose from, and then even outside of the actual school, hence, me working with Dr. Marco Longo, even though she's in a different department, again, there's that collaboration, right? It's that crosstalk between departments and ability to do research with somebody else, but still getting that biomed degree. I work with Michelle Marcolongo in the material science department, and so the research that I did, it was actually still more mechanically based, and that's what my undergrad degree was in. So I did mechanical characterization of the lumbar disc, the lumbar intervertebral disc, under high impact loading. So we were actually working with the Department of Defense. There were high rates of injury amongst that naval boat operator population. The goal was to better understand how the disc behaves mechanically under those specific types of loads, and then what the implications are for injury. I'm currently teaching Biomechanics 1. What I like about it, honestly, is that it's for a lot of these students, it's really their first foray, getting a deep dive into biomechanics. Part of what we do in this course is we talk about what are different applications of biomechanics. Where do you see these things represented, and how can you take what you're learning now and what kind of things might that apply to in the real world?